For decades, really, when we pictured Europa, Jupiter's moon, the image was always this still, silent shell. Beautiful, sure, but frozen solid, unchanging.
Kind of perfect ice world, yeah.
Exactly. But what if that picture is just wrong? Because new observations, these ones from the James Webb Space Telescope, JWST, they're hinting at something totally different.
Something much more dynamic.
Right. Less of a frozen artifact, more of a dynamic world. The suggestion is chaos reigns under the ice, and there's some really strange and exciting chemistry going on.
Mm-hmm.
So today, that's our deep dive, exploring how these frankly radical new findings are basically turning our whole understanding of Europa completely upside down.
That's the plan. Our mission today, if you like, is to really unpack how these JWST observations and, crucially, how they connect with lab experiments are painting this, entirely new picture of Europa.
A much more lively picture.
A much more lively one, yes. We'll dig into what it means for, understanding Europa's interior. And the big one, its potential for habitability. We'll look at the specific evidence, try and pull back the curtain a bit on this icy moon's secrets.
Okay, so let's start with that old picture. For so long, the surface was just seen as frozen in time, right? A static sheet of ice. How do these new JWST results challenge that? Like, fundamentally challenge it?
Well, what's really fascinating, this comes from Richard Cartwright, a spectroscopist on the study, is that the surface is actually, quote, fairly porous and warm enough in some areas to allow the ice to recrystallize rapidly.
Rapidly? Recrystallize?
Yeah.
What does that actually mean for the moon?
It's kind of a big deal. It means the ice isn't just sitting there getting bombarded by radiation for eons. It's actively changing, regenerating. Almost. It suggests fresh ice, maybe even stuff from below, is reaching the surface relatively recently. It points to a far more, active surface than we thought.
Okay, active surface. And that brings up these chaos terrains, right? These areas look like, like the ice just got completely jumbled up. Why are these messy-looking regions so important?
They really are messy-looking, but they're incredibly significant. These are areas where it looks like huge blocks of ice have, broken off, maybe floated around a bit, and then frozen back into place, but all jumbled up.
Like icebergs on an earthly ocean almost, but frozen in place.
Sort of, yeah. And the key idea is that they could be potential windows into Europa's interior. Studying their specific light signatures, their spectra, gives us clues about the chemistry underneath the ice. So they're not just surface features, they're hints about the inside.
Mm-hmm.
And habitability.
Right. Clues to what's going on deeper down. Okay, so let's zero in. The study looked at specific chaos terrains, Tara Regio and Pauis Regio in the southern hemisphere. And Tara Regio sounds particularly interesting.
It really is one of the most watched spots on Europa, yeah. And what JWST found there was crystalline ice, not just on the immediate surface, but evidence it exists deeper below as well.
Crystalline ice. Okay. Why is that significant compared to other ice?
Well, think about the ice we know on Earth. It has that nice, orderly, hexagonal crystal structure, right?
Uh-huh.
But Europa's surface is blasted by intense radiation from Jupiter. This radiation normally breaks down that orderly structure, creating what we call amorphous ice, disordered, non-crystalline, messy on an atomic level.
Okay. So finding crystalline ice deeper down suggests?
It suggests that ice is either newer, hasn't been exposed to as much radiation, or perhaps formed in or came from a warmer, more protected environment below the surface, maybe involving liquid water pushing it up.
Mm-hmm.
It definitely challenges the simple idea that the ice is just uniformly structured, or unstructured, I should say. It hints at complex layering and movement.
And understanding how this ice behaves under radiation, that's where lab work comes in. I know Ujwal Raut's team did experiments.
Exactly. Raut's team did crucial work in the lab, basically simulating Europa's conditions. They looked at how water freezes and how that ice changes when it's hit by charged particles over time.
So they recreated a tiny piece of Europa on Earth.
In a way, yes. And when you combine those lab results, how different types of ice should look under Europa's conditions, with what JWST actually sees from space, it massively strengthens the case. It supports this whole growing body of evidence pointing towards that vast, hidden liquid ocean beneath the icy shell. The lab work helps us interpret the telescope data.
Okay, so the surface is dynamic, the ice structure is complex. What about the actual chemistry? Did JWST sniff out specific chemicals coming from inside?
It certainly looks that way. And this is where Raut's quote is really powerful. He said, "Our data showed strong indications that what we are seeing must be sourced from the interior, perhaps from a subsurface ocean nearly 20 miles, 30 kilometers. beneath Europa's thick, icy shell.
20 miles? That's incredibly deep. That's like stacking Mount Everest on top of itself almost twice over.
Just staggering depth, yeah. It really emphasizes the scale of this potential ocean we're talking about. It's not just a little subsurface pond.
And what chemicals did they actually detect that point to this internal source? Is it just salty water or more?
It's more than just water. They found, quote, the best evidence for sodium chloride. Basically table salt, like you said.
Huh.
And also some of the strongest evidence for CO2, carbon dioxide, and hydrogen peroxide on Europa. Cartwright himself said, the chemistry in this location is really strange and exciting.
Strange and exciting. So table salt, CO2. That doesn't sound like stuff you'd just find lying around from space impacts, does it?
Well, that's the point, especially the concentration in these chaos terrains. It strongly suggests geologic activity is literally pushing this material up from beneath the ice shell. These fractured areas are acting like vents almost.
It's like the moon is actually venting material from its ocean.
That's the lunking hypothesis, yes. These chaos terrains seem to be the places where the shell is weakened, or where processes are actively bringing stuff up from below. It connects the surface features directly to the possibility of a chemically rich interior.
Let's talk about that CO2 specifically. You mentioned it was found concentrated in the chaos terrains. Why is that so compelling?
The key thing about CO2 on Europa's surface is that it's not very stable. That intense radiation environment we mentioned, it should break down CO2 over time.
Ah, so if it's sticking around in high concentrations.
Exactly. It suggests that deposits are relatively recent. They haven't been sitting there long enough to be destroyed. And because they're concentrated in these specific chaos areas, it implies they're tied to ongoing geological processes, bringing fresh CO2 up from inside.
Rather than just raining down evenly from meteorites or something.
Precisely. An external source would likely give a much more uniform distribution across the whole moon. The patchiness points inwards.
And wasn't there something about a specific type of carbon, carbon-13?
Yes, that's another really intriguing piece. They detected carbon dioxide made with carbon-13, which is a heavier, rarer isotope of carbon compared to the usual carbon-12.
And what does that tell us?
Well, Cartwright put it quite bluntly, where's this 13 CO2 coming from? It's hard to explain, but every road leads back to an internal origin. You know, it's in line with other ideas about the regular CO2 also coming from inside to our regio. Finding this specific isotope adds another layer of complexity and further strengthens the argument for an active subsurface, with potentially complex carbon chemistry happening down there.
Wow. Okay, so how did JWST actually make these detections? What's the magic instrument here?
The workhorse for this was JWST's NIR-SPEC instrument, the Near-Infrared Spectrograph. It's incredibly powerful.
What makes it so good for this kind of work?
It can detect those faint chemical fingerprints, the key chemical signatures, across a really wide range of infrared light. Things like crystalline water ice, and crucially that iniokiours. Plus, it doesn't just detect if something is there, it can create detailed maps showing where the materials are concentrated.
Ah, so it mapped the CO2 to the chaos terrains?
Exactly. That mapping capability, combined with its high sensitivity, makes it pretty much the ideal tool, as the researcher said, for finding these clues about what's hidden beneath Europa's ice.
This really does feel like a significant leap. All this mounting evidence for a dynamic surface, complex chemistry, likely sourced from a deep liquid ocean. It ramps up the stakes for the potential for life, doesn't it?
It absolutely does. You know, liquid water, chemistry, energy sources. These are the ingredients we look for. Finding evidence that Europa might have all three, potentially interacting beneath the ice, is huge.
So what's next? How do we follow up on these incredible hints?
Well, the really exciting thing is that the next step is already on its way. NASA's Europa Clipper mission is currently en route to the Jovian moon.
It's actually flying there right now.
Yep. Expected arrival is April 2030. And its whole purpose is to get a much closer look. It'll perform dozens of flybys, swinging low over Europa again and again, gathering much more detailed data specifically about that hidden ocean, the ice shell, and the surface composition.
So JWST gave us these tantalizing clues from afar, and Clipper's going in for the close-up.
That's the idea. It's designed to really characterize Europa and assess its habitability in unprecedented detail.
Okay, so to sum up then, the main takeaway seems pretty clear. Forget the still, silent shell. Europa is dynamic. There's significant internal activity, complex chemistry bubbling up, likely from a vast hidden ocean.
Absolutely. It's a fundamental shift in perspective. And, knowledge is most valuable when understood and applied. These discoveries are vital pieces of the puzzle, connecting what we see on the surface with the deep hidden processes, not just on Europa, but potentially on other icy worlds in our solar system and beyond. It really pushes the boundaries.
It feels less like astronomy sometimes and more like geology and oceanography on another world.
It really does. It's
Right.
planetary science firing on all cylinders.
So, thinking about all this, what does it mean for you listening right now? We have this confirmed strange and exciting chemistry rising from deep inside Europa. We have a dedicated mission, Europa Clipper, speeding towards it. What else might be waiting under that chaotic ice? What other signs of geology or chemistry, or maybe even something more profound might Clipper find when it gets that closer look? What secrets are still locked away beneath the ice?